titled The Alkaline Lie. So during this conversation, I will be uncovering and making very obvious why this whole concept of being alkaline in your body is such a healthy thing. What does it even mean? I'll talk about the different pHs, that refers to the acid-base balance in different parts of the body, and I'll talk about ways in which you can truly modify your pH in the areas that you need to. Okay, so let's begin with a brief disclaimer that this information is not a substitute for sound medical or health advice. It's for your education. So let's begin with this. Now, one time I was giving a presentation in front of over 700 doctors, and I asked a question which I knew would generate a lot of excitement. And I said to them, so how many doctors out there believe that we should help our clients' bodies become as alkaline as possible? And they were literally going, yeah, let's do it. I'm like, well, what do you mean? And then there were no hands up. Finally, someone lifts their hand and says, well, I heard that being alkaline will lower cancer risk, that it helps the body do this and body does that. Then I said, well, where should you be alkaline? And are there places in your body where you should not be alkaline? And they just looked at me with blank stares. So even certain health professionals get this wrong. So here's what we're going to cover. Who says that you should be alkaline in the first place? What is pH? This is just a basic conversation, by the way. What does pH have to do with your health? The various pHs in the different body compartments. What happens when our pHs are off in different areas to our health? How does the body manage pH balance? And how does one fix a pH problem? And important testing to consider for pH. So I'm going to start with this question of who says you should be alkaline in the first place? So let me paraphrase what I've written here. The body naturally regulates pHs in different areas of the body, and you should definitely not be alkaline in all areas of your body. And to my mind, when someone says you should be alkaline, they mean in your whole body. So for example, the stomach must have acid, right? So the stomach certainly should not be alkaline. If it were alkaline, that's what you accomplish when you drink, let's say, alkaline water, or you take an antacid. You make an alkaline environment, which actually impairs dramatically not just absorption of nutrients, but increases your risk of all kinds of other diseases, because we need stomach acid in the stomach to digest parasites and viruses and bacteria. And we also need a proper pH, acid pH of the stomach to establish immunity. So telling a person, as I've written here, to be alkaline overly simplifies a very complex physiologic system in the body. So if you overemphasize this alkalinity, like one client of mine, I saw her for the first time. She had breast cancer. She was drinking something. I said, what is it you're drinking? She said, well, it's alkaline water. Well, first of all, I tested the water, and it had a pH of about 7. So it wasn't alkaline to begin with. But if it was, she would be neutralizing her stomach acid. And as I just explained, that is a very undesirable thing, not just for people with cancer, but for anyone. So if a person follows an alkaline food plan, let's say, whatever that is an unbalanced diet. If they avoid acidic foods, let's say. Now, there are times when you want to avoid acidic foods, maybe when you have reflux or gastritis and ulcers, for example. But if you don't have those things, you don't necessarily want to avoid all acidic foods. So encouraging alkalinity ignores the true pH imbalances, the true pHs in the body, I should say, acidosis and alkalosis. Those are the extremes of the pH scale. We want to be in a tight range, as I'll explain later, for your blood pH. See, here's a pH scale. It's 0 to 14. 7 is neutral. We want water as 7. That's a universal substance. And for our blood, we just want to be just to the left of that pH scale at 7.35 to 7.45. We don't want alkaline blood. That's not even conducive with life. The body already has strong buffering systems. In other words, our lungs, our kidneys, for example, can buffer acid products in the body. And yes, you're right, they can become overwhelmed, and maybe you'll need some help with alkaline products. I'm not saying never take them, but we certainly don't want to take them for this reason of alkalinizing our whole bodies. So let's start off with what is pH, just a simple explanation. So pH literally stands for potential of hydrogen. And the more hydrogen atoms in the, or ions I should say, in the blood, the more acidic the person is. So pH stands for potential of hydrogen and measures the acidity or alkalinity of a solution based on a scale of 0 to 14. And as I mentioned, 0 is highly acidic, 7 would be neutral, and 14 is highly basic or alkaline. What does pH have to do with your health? Well, we need a certain pH environment for various enzyme systems to work. So enzymes run the reactions in the body, and they need a certain environment to do that. And if the pH is off, then it will impair enzyme activity. And many of these enzymes in the body that work a lot of different physiological processes in the body, they use or require, I should say, vitamins and various minerals as cofactors. So if your pH is off, either too acid or too alkaline, you're going to adversely affect enzyme systems and then also the use of various vitamins and minerals. We need enzymes also, as I've been mentioning, for enzyme activity, for nutritional absorption. For example, if we don't have a proper pH in the small intestine, then that means the enzymes that get secreted in the small intestine by the pancreas will not work properly or at all. We even need a proper pH for oxygen delivery. And not only that, but oxygen issues will change the body's pH. So if a person, for example, is hyperventilating, they tend to become overly alkaline. And then there's, just generally speaking, cellular metabolism. So how cells work, all the different organelles, the tiny little organs, you might say, otherwise known as organelles in various cells, they require a certain pH environment to swim around in, so to speak, or to bathe in for them to work properly. Extreme imbalances of pH can impair organ function and contribute to many different diseases, like diabetic ketoacidosis, which is a highly acidic problem. And when people have that condition, they are not doing well. They're usually in hospitals. So take a look at this. This really says it all. I'm a little embarrassed to say that some of my colleagues in the natural field, they don't understand even this basic physiology on this one slide. And most regular doctors have a clue about this. I am generalizing, but the regular physicians laugh when they hear these statements that, oh, I should be alkaline, or all cancer cells grow in an acid environment. It's not true. Now, I just mentioned cancer. So some cancers will definitely grow in an acid environment, but the combination of acid and alkaline effects for the body is really what determines how well someone is going to do in a condition like cancer or any other degenerative condition. So take a look. So in the mouth, the pH should be between 6.2 and 7.6. So a slightly acid to neutral, which protects the teeth and supports enzyme action. We also have immunoglobulins here, so that can all be upset, that oral milieu or environment there, if we don't stay in this pH. And then there's a very important starch digesting enzyme known as amylase, which works here as well in that pH. And the stomach, we need a 1.5 to 3.5. If we don't have a very acidic environment there, we're not going to digest our proteins, we're going to have malabsorption of a bunch of nutrients, and without the proper acid pH, we can't digest organisms in our foods. The small intestine, a 6 to 7.4. If we have a problem there, the enzymes, as I mentioned, and the enzymes from the pancreas that are secreted in the small intestine will not work well. And that's going to affect protein, carbohydrate, and fat digestion. The large intestine, 5.5 to 7.0. That's acidic to neutral, supports healthy bacterial flora. So we all know how important probiotics are. And if we're not within this pH, you can put all the probiotics in that you want. They will not work. Urine, 4.5 to 8. Venous blood and arterial blood. The point is, as you can see, based on this chart, require different pHs. So what happens to our health when pHs are off? So if it's too acidic, if a pH is dropped too low, that can cause acidosis or a subclinical subclinical acidosis, which means the person is walking around, but they've got these problems. Usually when a person has a very severe acidosis or severe alkalosis, they're in a hospital bed. So with acidosis, we can have fatigue, confusion, shortness of breath, renal stress or kidney stress, and many other health problems, many. All the degenerative conditions from osteoporosis to arthritis, everything is bathing in an acid environment, and when that happens, things break down. A loss of lean mass, like organ mass, which is directly associated with poorer lifespan, shorter lifespan, more degenerative conditions. And when we have alkalosis, we might have muscle twitching, hand tremors, nausea, poor detoxification. When we're too alkaline, you see, reduced immune function, and various metabolic disturbances. So the take-home message is we want to be acid where we're supposed to be acid, and we want to be alkaline where we're supposed to be alkaline. So how does the body manage our pH systems? The body uses three primary systems to manage pH in the body. One is a buffering system, which especially the use of what's called the bicarbonate buffer in blood. Then there's the respiratory system. Exhaling CO2 reduces acidity. I may have actually stated that opposite earlier. So exhaling CO2 reduces acidity because CO2, if it stayed in the body, becomes carbonic acid. So if we're blowing off the CO2, we're going to produce more of an alkaline state. And then there's the renal system, or the kidneys, that excrete hydrogen ions and resorbs bicarbonate. So absolutely fundamental systems just on this one little chart that need to be considered when trying to balance someone's pHs correctly. So how does one fix pH? Well, you want to treat the underlying cause or causes. You don't simply take a product that is claimed to fix pH. How could you do that? What if there's an underlying kidney issue, or there's a pancreatic issue, for example, or there's a lung issue? You'd need to know these things. So maybe if your pH is too low, you would want to have alkalinizing foods like certain fruits, vegetables, less processed food. You want to avoid excessive protein or sugar. You want to use alkaline water cautiously. So I'm not a fan of alkaline water except for some digestive issues like I mentioned them earlier, esophagitis, gastritis, and ulcers, because it's good to lower the pH in that way, particularly in clients that I have that do not want to take the proton pump inhibitors or those antacids. The pH water is about the only thing I think it's good for. Now, I will sip pH water when I run marathons in a camelback, and where the water is going into the alkaline water is going to my mouth, because during that sort of rigorous, sustained effort of running a marathon, the body develops and accumulates lots of acid products like lactic acid, which is responsible for people hitting the wall. I never hit the wall because I am diluting the stomach acid the whole way of the race by sipping on alkaline issues. So based on various lab tests, that helps me figure out what and where I need to adjust pHs. So important tests, there are arterial blood gases, or ABGs. There's serum bicarbonate, that's on a regular blood test that tells us about pH. Various electrolyte panels, anion gap, urine and saliva pH, and lactic acid levels. That's just some of the ways I might monitor pH. And then, based on that, I prepare a food plan for people that is specific for their needs. Sometimes that involves timing of certain foods that are alkaline, more on the alkaline side or more on the acid side. And remember, just as a parting message here, that when you eat something that's acid, it might end up helping your alkalinity in various areas of the body. And if you eat something alkaline, it might help you manage some acid areas of the body, because these foods are processed and then they might support different tissues like those I just mentioned, which help the body regulate its pH. So all of that is considered, and then a food plan is put together for a person, the proper exercise plan, supplement plan, those sorts of things. So I hope that you found this somewhat important and hopefully understandable. Let me know your thoughts, and I'll see you at the next podcast. Thanks so much for joining me.